Okay, so we're going to be looking at finding the probability of unions and complements and intersects. Hopefully this is going to be a nice recap of what we've already been doing in class. Okay, so a fair dice is thrown. Write down the probability of these events. So nice and easy. Probability of you getting a 6 on a dice when you throw it is 1 out of 6. The probability of you getting an odd number when you throw a dice is going to be 3 out of 6, which is half. And then the probability of you obtaining a prime number on a dice is again a half, so 3 out of 6. The probability of you obtaining a number that is less than 6, not including 6, will be 5 out of 6. So be careful with the inequality. Okay. So please interrupt me if there's something that you didn't understand, or you can just type it into the chat if you feel more comfortable doing that. Okay. Okay, so probability of you obtaining a 1 or a 5 is going to be what? Any ideas when you throw a dice?
6.
So it's going to be the probability of you obtaining a 1, probability of you obtaining a 5, which will be 1 out of 6 plus 1 out of 6, which in turn will be 2 out of 6. Remember the OR rule. So when it's an OR, then you need to add the separate probabilities together. If it was AND, you would need to multiply them, okay? So that simplifies to 1 out of 3. The probability of you obtaining an odd or an even, well, the probability of you obtaining odd plus the probability of you obtaining even, which is just going to be 6 out of 6, which is 1. Okay, so 100% chance. Probability of you obtaining a prime or even. So again, you do them separately, adding together because it's an OR rule. So that's 3 out of 6 plus 3 out of 6. So that's a whole again. Okay. Why is the last event incorrect? Any ideas? Any ideas? Okay, so we've got probability of A, union B, union C. So all of A, which is pick a heart, all of B, which is a king, and then all of C, so numbers with 3, 4, and 5 on them. So that's in total 25 out of 52. Next one. Okay. So we have the probability of B union C. So again, picking a king, which we've highlighted here, picking numbers, cards that have 3, 4, and 5, which we've highlighted here, but that intersects with A. So it'll be everything here that's a heart, but where does it coincide? So it coincides here, so 1, 2, 3, and it coincides here, 4, okay? So that's 4 out of 52. Okay. This one's quite long here. So we've got A intersect B. Oops. So this is also actually the same. So I'm sorry about that. I just moved the cursor. So it was A intersect B. Okay. Union A intersect C. So A intersect B. So that's A, B. So we find all the hearts and find where does that coincide with your kings, which is here, 1, that's just 1 card. And then A intersects C, so where do these two coincide? 1, 2, 3, so it's 4 cards in total. So basically this was 2 ways of writing the same thing. Okay, any questions so far? I will put the slides up for you in case you want to go through these again, and I am recording this. Okay. Okay. Let's have a look. Okay. Let me just pause. So basically, let me write on the screen. Hopefully the slate will work. So if you have a look, let me show you. Oops. Okay, so basically, if you just ignore the complement here and you find the probability of B intersect C, it's 0. Oops. It's equal to 0 because you cannot find a king that has a number 3, 4, or 5 on it. Okay. In fact, none of them have 3, 4, and 5 on it if they're a king or queen. Okay. So they don't have any numbers on them, so it's 0. So to find the complements, you do 1 minus the probability of B intersect C, which is going to be 1 take away 0. Whoops, 1 take away 0. Sorry, I didn't have any space there, which is just 1. So that's why that one there is just 1. Is that okay, Faiza?
Yes.
Okay, perfect. All right. Okay, the time to see what it is. Okay, so we still have time, which is good. Okay, copy and complete the two-way table. So here we have maths, 21, male, female, 27. Okay, right, so we have event A, B, C, M, and F. All right, so we need to fill it out. So let's have a look. Okay, let's see if we can fill it out. Okay. Okay, so we've got both of them added together, which gives me 48. Then if we look here, we can work backwards. We know that the total number is 100. Okay. So total number of students is 100 because that's what they gave me in my question. They said it's 100. Then I can just subtract that from 48. You can subtract 48 and 18 from 100 to find the total number you're studying English as well. And you work backwards to fill out the rest of them, okay? Right, so hopefully that was nice and easy just to fill out the table. Probability of A complement, so not A. The probability of not A occurring, so doesn't pick maths. So how many students don't pick maths? So that's going to be here and here. So it's going to be 18 plus 34, okay? And that's going to give me 52, all right? Then we've got the probability of A union B, so A and B. So picks maths and picks science, okay? So picks maths and picks science, okay? So that's going to be 48 plus 18, which is 66. Okay. Picks A, so A intersect M. So picks maths, but also is a male, okay? So picks maths, but it's also a male. So basically boys that have picked maths. So let's have a look. So that's going to be 21, okay? So it's only 21. The probability of the complement of B, so not B occurring, okay? So not picking science, which needs to coincide with, so it doesn't pick science, but is a male. So that means it's going to be 12 plus 21, okay? So you've got 12 plus 21, which is 33. That's 33 students. Any questions so far? No? Okay, next one. The probability of C union complement of F. So we look for the probability that the person picks someone who studies English, but they are not female. So basically male. So boys who have studied or have picked English, okay? So we've got here, it will be 68. Okay, so it's the union of students who pick English, but not female. Okay, so it's all of these added together, 21 plus 13 plus 12. Yeah? Hold on, no, that doesn't sound right, does it? So we've got the probability of C occurring, which is you pick English, union, not female. So not female. So we can't, so they definitely pick English, but it's not female. So it's the union of all of English, but not female. So it will be all of these added together. So it is 68. So 2, 3, 4. So that's 46. 46 plus 22. So we've added all of these together. But it says the not female. Can anyone see if they've made a mistake? Or do we agree with it? So let me just check. So you've got the probability of C, and then you also have the probability of the complement of F. The complement of F is the student is female, but the student, so the complement of F is not female. So it's everything that's not female. And where does that coincide with here? I would have thought it was 12 out of 100. Oh, it's the union. It's not the intersect, it's the union. So it's all of them added together. Yeah, it's all of them added together because it's the union. So it's the union of all the students who study English. So that's everything, everyone that studies English, okay? And students who are not female. So students who are not female, so basically everyone that's a male. So that's all of this. And when you add them together, you get 68, okay? Any questions about that one?
Yeah, miss, 1 second. So if you, why do you add all of them? Like,
because this union means everything, right? So you're going to include all of it. It's everything. So if you take them separately, so you find probability of C occurring, so picks English, so everyone that picks English, right? And then you want everyone as well who is not female. So that's all of this, right? That's all they're saying. So then that's why you add them together. It's not the intersect. So it's not probability of C intersect the complement of F, because that would just be 12 out of 100. Because that would just be here. Yeah?
Miss, do you add 22 as well?
Yes, you do. You add all of them because it's the union. It says union. Yeah? It's just saying, please add everyone who's studying English and also add to that everyone who's not female. Okay?
Yeah.
Is that okay, Faiza?
Yeah.
Okay, so A union F, so all of A for the next one. So picks maths, so everyone who picks maths, and also all the girls. So that's going to be 22 plus 5 plus 27 plus 21. So that gives you 75 out of 100. Okay, now intersect. So what you do is highlight all of B, so everyone that picks science, and how many of those people who study science are female? 5. So it's just 5 out of 100. Do you get that? Yeah? Okay, next one. The complement of B, union M. Okay, so the complement of B. So doesn't pick science. So in other words, picks maths and English. Union is also a student, is also male. So basically all of the males, and also including doesn't pick English. Okay, sorry, doesn't pick science. Okay, so then you had 27, 21, 13, 12, and 22. Okay, so it's union. So union means you're adding them up all together, all of them. It's the entire group. Okay, so 27 plus 21 plus 13 plus 12 plus 22, even though some of those students are female. Okay, because the fact is that they want to know who doesn't pick science and add that to the number of students who are male. Okay. All right. Any questions? No? Okay. Right, Venn diagrams. What I'm going to do, I'm not sure if we have enough time, but I will wait and see how long we have. And if we do run out of time, I'll just carry on with the video and put it up on the Google Classroom and YouTube for you, okay? So Venn diagrams. So Venn diagrams are a really good way of illustrating events within a sample space. So it makes it much easier for us to see what's going on. So we have our sample, so it's a set containing, so we always use the curly brackets when we're looking at sets. So these curly brackets are very important. The curly brackets mean something different to these solid brackets, okay? So we only use these curly brackets when we're dealing with our probabilities, okay? Okay, so next. We draw a closed rectangle, which denotes this is everything within our universe that we're looking at. S denotes our set. Okay, sometimes we use epsilon, okay, to denote this, which is like that. Okay, it's a little symbol, epsilon with the little curly tail, okay. All right, so we're going to put our numbers in. Now, we're going to let A be the odd numbers. Okay, so we're going to put all our odd numbers in there. And any numbers that are not odd will go on the outside. Let B be the factor of the number 24 and draw a circle to represent where the circles overlap. Okay, so we're putting B being the numbers that are factors of 24. And all the numbers that don't belong in A will stay on either event B or outside if they don't coincide in A or B, okay? Okay, so here we go, it makes it much easier to see what's going on. Sometimes they don't tell us in the question that we have to draw a Venn diagram, but it's much easier if we do draw a Venn diagram, okay? So the probability of getting a number that's in event A is going, and not in event B is 3. Okay, so 5, 9, and 7. All the regions in the Venn diagram can be changed to probabilities in the same way, okay? So we can change these into probabilities. So instead of writing the numbers individually, we can write the center as 2 out of 10, and then here 4 out of 10, and then outside 1 out of 10. If any of the region's probabilities are unknown, can they still be calculated using the Venn diagram? The answer is yes, because you could just do 1 minus the probability of it occurring, okay? All right, so this is the bit that's actually quite challenging. So it's matching, some of them are challenging, some of them are quite easy. Okay. Right, what is the correct notation for the first one? For the first diagram. Nuruddin, what do you think? Oops, oh, I've answered that one for you. So that's just the probability of B occurring. What about the next one? Nuruddin, you answer this one. Karen?
I don't know if it's the A, not that
Complement.
Yeah, complement, and then the N, and then B complement.
Okay, perfect. Well done. Excellent. Well done. Next one, Zach, what do you think?
A, not B.
So A, not B. Okay. Any other ideas, Sarah? What do you think?
I think the same one that he said.
Okay. So it's B complement, so it's not B. So everything else is shaded except for B. Okay, so that's B complement. How about the next one?
A union B.
A union B. Well done, that one's easy. Next one.
A intersect B not.
Okay, so A intersect. So really quickly and do the last three. So this is just the intersects. This one's quite nice and easy. And this one here is A intersect the complement of B. So it's all of A, and this intersects with the complement of B, so not B. Okay. And then the last one is just the complement of the intersect. So you think, what's the intersect? So A intersect B, which is the middle. So it's everything except for the middle. Okay. Right, I'm going to carry on with this video. I'm going to let you go. Okay, so I just wanted to go back to this problem here because I noticed that some students were a little bit confused. These ones were the ones that caused the most confusion, and I've just highlighted it in yellow, okay, so you can see. So if they've asked you to identify A intersect complement of B, what I do is I first sketch, I first shade the complement of B. So this is the complement of B, we already did this one. But where does that then coincide with A? So remember, this symbol here means intersect. So where does that intersect with A? Well, it intersects here. This is where it coincides. So that's why they've drawn only this bit here for A. And then for the next one, they have asked us to do A union complement of B. So treat the union here as if you are saying and, A and the complement of B. So you've got all of A, so we've got the complement of B, which we've got here already, but you also want to include all of A. So that's this bit here as well, which is why they shaded that in here as well. Okay, right, so next bits. Let us move on. So here we go. We've got the probability of A union B, and then we have the probability of A plus the probability of B. What you can see here is that we have, if you find the probability of A union B, what you've done, if you do the probability of A plus the probability of B, you end up including the middle bit twice, okay? So the probability of A union B is going to be the probability of A plus the probability of B, but you subtract the intersect because you've already included it. So you've basically, what you've done is you've worked out the probability of A, and then you've worked out the probability of B, but in doing so, you've included the middle part twice, okay? Which is why you subtract it once. Okay. The probability of A intersect B can be, you can then rearrange that. So if you take that over and take the union over to the other side, is the following, okay? Right, I've got here some exam questions for you guys to go away and have a go at. I will put them up on the Google Classroom for you to go through, and the answers are at the end, so you need to scroll down, okay? So in a group of 10 people, 2 are left-handed and the rest are right-handed. A person is randomly chosen from the group to have their handedness checked. After this, they return to the group, and then this process is repeated 2 more times. What is an appropriate way to find the probabilities of the outcomes? Okay, so let's have a look. Oops, sorry. So you show all the possible outcomes using a tree diagram, okay? We've got right-handed, left-handed. And then again, right-handed, left-handed, okay? And then we've got another event as well. So you've done this 3 times. Okay, so we write out our sample space. And then we find the probability of getting multiple events. You then need to multiply along the branches. You always multiply along the branches, okay? So you've got right-handed is 8 out of 10. We're told this in the question. They said in a group of 10, 2 are left-handed and the rest are right-handed, okay? And then we do the same if necessary for the rest, only if necessary, depending on what the question was. And remember, you are multiplying along the branches, okay? As this is every possible outcome, the probability should always add up to 1, which they do, okay? So, on whiteboards, write down the probability of getting 3 people with the same handedness. So that could be right, 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 or left, left, left. So in this case, you add those probabilities. So 512 plus 8, okay? So that gives me 520 over 1,000, which you can then cancel down. Probability of exactly 2 left-handed people. So that could be right, left, left, or it could be left, left, right. Okay, but it says exactly 2. So you only want those 2 probabilities. So 128, 32, and then you've got 32 again, and exactly 2 here, 32. So you would add those up all together, and you've got 96 over 1,000. Write down the probability of getting at least 1 right-handed person. So at least 1, so it could be 1 or more. So it could be the first, or it could be the next one, or this one. We've got at least 1 here, at least 1 here, and here, and here. So you add them up all together, and you've got 992 out of 1,000. Okay. And then last one, probability of getting at most 2 right-handed people. Okay, so at most, so that's 128, so you've got 2 here, 2 here. We've got 1 here, 2 here, another one here, another one here. So it's at most. So that means we can't have 3 rights. So the highest number of rights we could get is 2. Okay, so basically it's 2 or less. Okay, so we have another scenario. Okay. So this time, a person is randomly chosen from the group, and this time the person selected is removed from the group. So it's not replaced, okay? So the person is not replaced, basically. So you have 1 less person here. So you've got 9 people here, and then you have 8 people in the next event, okay? So our probabilities will therefore be different this time, but they should all add up to 1. Remember, you're multiplying along the branches. If the probability of the second event depends on the result of the first event, we say that these are independent. We say these events are dependent. 2 events are independent events if the first event had no effect on the probability of the second. This can be written as so you have the probability of A intersect B is therefore equal to the probability of A times the probability of B. Okay, so they are independent events. They are not reliant on one another. Okay, so there's another exam question here for you guys to have a go at. So what you need to do is look through the exam questions that I've given you and complete them and upload it to the Google Classroom. Okay, any questions, please let me know.